G'day viewers, a little video on inductors. Now I'll take it that you already understand what inductor is, that it's a winding. What we're looking for from the inductor is obviously the magnetic field. And that magnetic field is created because of the current going through the conductor. So another video will go through about how the current creates the magnetic field, but for now we'll just know that the inductor has a magnetic field. Now that magnetic field is created because of the current. So the inductor uses the current to create the magnetic field. Now the inductor is a little bit on the selfish side. So what the inductor will do, will use that current first to build up its own magnetic field first. Only after the magnetic field has been built will it then allow the current to continue on through the rest of the circuit. So a little bit of an issue that causes for us. Here we've got basically an oscilloscope. So on here, normally we would have, let's say if we've got the, we flick a switch and we've got the voltage, that's the sine wave of a voltage, and then of course our current would be in step with it. Like that. So there's our voltage, there's our current. But when we use an inductor, the inductor is going to use the current first. Doesn't care about the voltage, doesn't want the voltage. So what happens is that what we see is that a period of time, so this line represents time, and that's value, so that's how many volts, how much current, and how much time. So what happens is a short period of time after the voltage has started, we then get the current is going to start. You notice that the current is now out of step with the voltage. Now, if you can imagine, you've got a 2-horse race. So you've got 2 horses sitting there ready to bolt. We let one gate open first, that's the voltage. Boom, voltage horse goes. We hold the other one back. It's not exactly a decent horse race, is it? And then after a period of time, we let the gate open for the next one. We don't want to do that. We would like to keep the horses close together. There's nothing we can do about that though. We cannot make that any quicker. We can't make the current go through the inductor quicker and then go into the rest of the circuit. We could change the inductance in the circuit. So those of you who have already been to college and understand inductance, yes, we could change the inductance in the circuit. But then it wouldn't be the run characteristics of the motor or the solenoid or the contactor or whatever it is that we want to use. So what we can do though is if we could find something that doesn't care about current. If we could find something that is going to want to be selfish with the voltage, and so it uses the voltage first and allows the current to virtually pass through. And I know you've all got the answer. It's a capacitor. So the capacitor is going to build up a charge, and that video I did a couple of days ago we're showing that the toilet system is just like a capacitor. The capacitor is going to use that voltage to build up its charge first. Once it's built up its charge, then it allows the voltage to go through the rest of the circuit. The size of the capacitor will determine how long the voltage is going to take before it goes into the rest of the circuit. So what we put in there is a capacitor that will build the charge close to the inductor for the same time. And now we've got our two horses that are being let out of the gate at a similar time. That's it. It's as easy as that. Hope it helps. See you tomorrow.